The topic for this video is the Gram-Schmidt orthogonalization process. So to start off, suppose we have a vector space V that has dimension n. Well, we know that there is a basis out there that has n vectors, and this basis corresponds to the vector space V. And remember that a basis is a set of linearly independent vectors that span the vector space. We're going to attach to this vector space V an inner product. Remember that an inner product is a map that takes pairs of vectors from V and sends it to a real number. And an inner product also has to satisfy three conditions. You might want to review what the three conditions are, but I'll repeat them quickly. The first condition is that the inner product of a vector with itself has to be greater than or equal to 0, and the inner product is actually only equal to 0 when the vector is 0. The second property is that the inner product is symmetric, and the third property is that the inner product is linear. So if you have these three properties with a map, it's called an inner product, and when you attach this inner product to a vector space, we call it an inner product space. So we have a basis already for our vector space, but what I want to do is I want to find a new basis. And we're going to call it B hat, and it's going to have n vectors because it has to have n vectors for it to be a basis for a vector space of dimension n. And we want this basis to have a special property, and that basis needs to have the property that when I take any vector in the basis with another vector in the basis, I either get 1 or 0. And the only time I get 1 is if the inner product is the vector with itself. And if I take the inner product of a vector with anything else, I get 0. And this basis is called an orthonormal basis because it's an orthonormal set. The length of every vector in that basis is length 1, and they're pairwise orthogonal. So every pair of vectors are orthogonal. So I want to come up with this basis, but how do I do it? And that's where we use something called the Gram-Schmidt orthogonalization process. Now, if we have the vector space, for example, let's say we have V is equal to Rn, and we have the inner product, just the normal inner product, then it's really easy to come up with an orthonormal basis. The standard basis is an orthonormal basis, where E1, E2, En. If you take the length of each one of those vectors, recall that E1 looks like this, and EI has a 1 in the ith position and 0s everywhere else. If you take the length of these vectors, they all have length 1. That's, by the way, this is ... not a 1. Maybe I should make that a little clearer. Yeah. So if I find the length of E1, I get 1, and actually the length of any EI is 1. And if I take the inner product of an EI with an EJ, I get 0. So that's a really easy and a quick way to find an orthonormal basis. But the thing is, if we're dealing with another vector space, like the polynomials of degree n minus 1 or less, and we have some strange inner product, it might not be easy to find an orthonormal basis from scratch. You might have to do a lot of work. So what we're going to learn is a way to find an orthonormal basis based off of basis you're already given. And that way we can come up with a nice algorithm to help us find this basis that we can use all the time. We can always use this algorithm. And that's the Gram-Schmidt orthogonalization process.